to close the event, the next talk, final talk in the event, comes from a guy that I admire. The first time I saw Eduardo on stage was in the Vue Amsterdam in 2018, and he did a really nice talk about transitions, very nice stuff that I used in my talk last year in the Vue Day Alicante. I'm really looking forward to this. He's from Malaga. I was thinking he was from Barcelona for a reason. He lives in Paris, and he is, I think, the only Spanish Vue core team member, I think. So, ladies and gentlemen, Eduardo San Martín.
Thank you, everyone. Can you hear me well at the end of the cinema? Okay. Because I moved this away a bit so I don't breathe on it. What? Okay. I see. So the picture you're seeing right now is the only serious picture in the presentation. The talk is technical, and I'm sorry. I know it's the last one of the day, not the best moment to have a technical talk. So that's why I replace every other single image with something less serious, and hopefully will make the whole thing a bit more smooth for a closing presentation. My name is Eduardo. I'm from the Vue core team at freelance. I live in Paris, even though I was born in Paris. Sorry, in Malaga. I was not born in Paris. And you can find me around the internet as Posva, so P-O-S-V-A, very easy to pronounce for a Spanish speaker. And I've been working on Vue and this ecosystem for 4 years now, even more actually, but on the core team for 4 years, or 3, always forget. And Vue Router is one of my most precious contributions. So it's where I spend most of the time, and I've been spending quite some months lately, many months, working on a new version and investigating what is wrong, what we could improve, what should be removed, what should be added, what people is looking for, and at the same time trying to add, fix the bugs, add the features that are really needed, etc., etc. So I really want to talk about this topic to show you what the direction we're taking for the Vue Router, and how you can contribute, or how it does affect every other Vue developer. And the thing is, the Vue Router, or the router in general, is a very interesting layer of your application, because it will touch many different parts and layers of your own application, like the internationalization, the fetching, localization, internationalization, the same, accessibility, and many other aspects. Now, when you start an application, so this is a picture I forgot. When you start your application, usually the first week, everything is super cute. You have one file, you have maybe 50 lines, 100 lines with the routes. And we all know that as we keep growing the application and we keep adding things, it doesn't get to the same point. It becomes another beast. And these could be applied to pretty much any code, to be honest. And I want to reassure you by telling you that the router is no exception to this. And we have also a lot of we have technical debt, and we have to deal with that in a complicated way, not to break stuff in between major versions. So it's not always that easy. And for those who don't know, the Vue Router API, it's very simple, very straightforward. You create an instance of a router, you pass an array of routes, and that's how you define what component is going to be displayed for this specific route. And then you can use 2 components, the router link and the router view, which doesn't appear here, by the way. The way it works behind the scenes is we have the components communicating with the router instance, and the router instance is communicating with the history. Now, the history is a private part of the framework that you don't have access to, at least in the public API. It's not documented because we don't want you to access this entity. So the components and the router are pretty much the public API of the Vue Router. And if we want to specify a bit of the responsibilities or the APIs that we have on these entities, we could say that the history is supposed to store the visited URLs and is supposed to handle the bridge between the JavaScript and the URL. So it exposed some APIs like push, replace, which are actually the same as history.pushState and history.replaceState. And you also have this listen function that allows you to know and to be notified whenever the URL, so in the case of a browser, the URL bar is modified, so you can act on that. And for the router, that will be triggering a new navigation, triggering the guards, etc., etc. And then we have the router, and the router has three main aspects. Now, the first one will be the route matching, which usually contains these two functions, although they can be simplified into just one of them. Match and resolve are going to transform a row location, we call a row location, which can be a string or an object, into the record that represents the route you want to point to. And then the navigation is gonna be what is the current route we are on, so pushing and replacing the URL, so that will be trigger the navigation guard, change the URL, etc., etc., and having the navigation guard, so the v for each, per component v for each, etc. But we can also create routes. We can create routes via the new router, but also by using add routes. And then the last part of the public API is are the components, router view and router link. So when we look at all of these, we might be asking, okay, what about the other routers? Do we look at each other or just copy the code we have? So the answer is sometimes yes. We do have a lot of code in common. So I want to talk to you about the other routers that exist out there and how they differ from the router, the Vue router. So from my experience, what I see is that we have three kinds of routers. We have the imperative one, we have the declarative one, and we have the configuration-based one. Now, Vue router is a configuration-based one. And if we take a look at, for example, Page.js, which is the same API as Express, is inspired by Express, well, that would be imperative router. So it's very simple and very flexible, but it's very verbose. Because it's agnostic, you cannot have any component. You have to handle everything through functions, through callbacks. So you are going to use the exact same function for adding routes, setting the guards, and also to do the navigations. They only have one function. It's called page. That's it. And if you want to list all the features we have, you can say that you write the routes in an imperative way. You have a programmatic navigation, calling the page function with the route. You don't have declarative navigation, which makes sense because you don't have any components to link these two because page is agnostic. And you have navigation guards, which could also be called middlewares if you have done some Express. So they are basically functions where you have to call a callback to say, I accept the navigation, you can go on forward into the next middleware, or you can drop the navigation and cancel everything. And you don't have dynamic routing, so you can add routes, but there is no way for you to remove them. Of course, you can add routes because you have an imperative way of adding routes, so that's the only way you can do it. If we look at something very different, we have the routers for React. Now, the most common router for React is still React Router, but I'm showing you React Router because the part that interests me is the same, is the declarative and dynamic routing. And if you ever want to take a look at some code base, I would recommend you to look at the React Router because it's much, much smaller and it does contain a proper separation of concerns, I would say. It's easier to read. Now, the key of the routers in React in general is that they have dynamic routing. And this is key to the behavior, to the way you code the routing in your applications. So basically, you have a function in the router instance where you can add and remove a route. Of course, you don't have this API in React because they don't want you to use the router instance directly. So what you do instead is you call a router component, and inside you nest other components to say, for this route, you're going to show this component, etc., etc. And then you have pretty much the same as Vue. You have more components, but you also have the link, and you also have the view. You also have the view component. Now, if you want to summarize, React Router is idiomatic for React. It works well for React. It wouldn't work well for other frameworks because it wouldn't match the way you think. So you write the routes in a declarative way. you have a programmatic access to the navigation, although it's in GS6. By that, I mean that you don't have access to the router instance per se. You have to extract it in the GS6 and then you can use it. You have declarative navigation because you have the link, for example, and you also have redirect. You don't have any navigation guides. This is something you have to do by yourself. So you have to create some higher order components to handle the navigation. And I can tell you that it's not that fun and it's not that easy. And you definitely have complete dynamic routing. Now, if we go back to the Vue router is different because we have a decoupled version. We have the router instance, which is one part of the public API, and we have the components, which is the other public part of the API. So we have a configuration-based routes. We do have programmatic navigation. You can call functions on the router instance. You have declarative navigation, and you have navigation guides baked into the framework. You can call before each. You have before enter in route records. You have before route enter in components. But we have a partial, not complete dynamic routing. Just so you can add routes, but you can really remove them without using internal things. So that's not ideal, as you can imagine. And the reason we have that is something we will cover later, but is related to the fact that we have a configuration-based API. Now, among these things, we still have some good stuff that we want to keep for the router. So this is the present of the router that we want, that we like. And I'm going to show you some of the APIs that are not likely to change because they have been proved to be good. They have been proved to be easy to use and beneficial for any developer. So the components obviously are not going away, as you can imagine. But to go very quickly through their behavior, the router view is communicating with the $route. So it's reading from there and saying, okay, this is the view I have to display, this is a component I have to display, and I can pass props to that component or anything. And that's pretty simple. It's a bit more complicated in the practice because it has to handle the keep alive components, if you have heard about them, and that's a bit more complicated. It also has the depth, so you can have nested views into each other. You have to know what is the depth level of that router view. But fairly simple compared to the rest of the code. And then we have the router link, which is a bit more complicated because it has more responsibilities and it communicates with the route and with the router itself. So it will resolve the target location, means that it will transform that link / that you see, that string or that object name, user params ID to an actual string that represents a URL. If you have query params, it will stringify the query params as well, etc., etc. After that, we have to render the anchor tag and then use that link. We have to handle the click event and prevent, and we have to apply the active class, which is a bit more complicated, and I won't go into detail. But the thing that makes this a bit more complicated is that we also have some edge cases that's being able to extend the router link, and it's not completely perfect nowadays, but it's still something we want to keep. We want to keep the simplicity, being able to just put something inside that router link and just work. We have a link that works. And just in case, the route that you see everywhere, the route, is a normalized version of the location. Now, the normalized thing is something important because inside of the code base, we're always dealing with normalized version, except for the functions which are a public API. So we accept raw locations like a string or an object that does not have a query or a hash, but then we transform them into an object that always have all these properties so we can deal with them more easily without having to check if, route.params, etc., etc. And when you're using the route, you have a normalized version, which means that you always have params, even if it's empty. You always have meta, you always have a query, you always have hash, which doesn't appear here, etc. Also, it allows you to have this declarative behavior that you can have in your template or in the JavaScript. So you can use the ID, display it somewhere, and you can call any fetch function, whatever you want. The same for the router, and I just want to say that the router is basically the instance of the router. This is nothing new there. Just, if you export the router and you import it somewhere else, that will be the exact same value as the router. And the only point of having this is being able to do programmatic navigation. Pretty much like this. Okay, so global guards is another API that we actually care a lot about. We have many kinds. We have 3 types of global guards, and it's important to know the difference. So the global guards that are the one that you attach to the router, and they're going to be applied to every single navigation no matter what, unless you break out of the function inside of the function itself. And you have always, so the thing about the guards is that they all have the same signature. They all have these. This is the target location I want to go to. This is the target location I'm coming from. And next is the function that we have to call every time in every single guard only once to say if we want to redirect to another location, abort the navigation, or confirm the navigation and just let the guard queue go on. So these are the global guards. They apply to every single navigation. But then we have the per route guards, which are applied to a specific route in your route config. But they are still global in a way when you think about it. They are still in the same file, in the router.js. And then we have the in-component guard. And now the interesting fact about these guards is that they are inside of the component. So we have 3 kinds. We have the before route enter, before route update, and before route leave. But because they are inside of the component, if you split, you code split your application, they will never be called before awaiting your component, before fetching your component. And the thing is, if you have a guard before that doesn't allow the user to go further, you will never actually trigger the network request to get that component. So to give a more specific example, we are on post, we want to go to admin, we call the before each. Inside of the before each, we have a next callback that lets the navigation go through. Then we go into the before enter, which is in the route record, and then we can maybe call next false. And because we call next false, we're dropping the navigation, and the admin.vue file, which is in a chunk somewhere code splitted in your application, will never be fetched, and we will never execute the before route enter. What I'm trying to show you here is that all the navigation guards are an asynchronous queue, and we have to wait for every single one of them before going into the next one. So this will shape a bit the way you put the navigation guards. So where do you put them? Do you put them in a global guard because they're going to be used everywhere, or is it something very specific to your component? They also have all the properties, of course, like before route leave allows you to prevent a navigating away from a component. So if you're editing a form, whatever thing, you can prevent the user from going away. So the way it works when you have a chunk is if you were on pause, you're going to go to admin, we're going to trigger the before end, we say, okay, let's go into the next one, and here we're removing the before enter, so we're going to trigger the network request for this admin.vue file, so we're going to await that, and once we have it, we're going to read the before route enter, which is a function that you have in the component declaration, and you're going to execute that, and after that, you're going to just go into the next page. Okay, this is all for the good parts that I want to just show you, and what I want to talk about is the sad parts. So the parts that are a bit more painful nowadays and that we are changing in the new Vue, in the Vue router, and also why it's not that good. So the most sad or ugly part of the code is that there is not a very clear division of responsibilities. And this can be seen very clearly with the router and the history. So these two entities can clearly overlap in their responsibilities as classes. And I'm going to give you an example, but the thing is, because they overlap in responsibilities, when you want to contribute, when you want to do a fix, you don't know you have to do that in the history class, or you have to do it in a router class. And if you want to contribute, it's also harder to contribute. So this brings some sadness to you as a maintainer or as a contributor, because it's harder to do. So to give you an example, router before each, the guards. So this is the global guard. This is the actual code, de-refactored to make it clear, and with TypeScript, that we have to add a guard. So as you can see, you have these before guards.push. We have an array inside of the router class, or the router instance, that is going to hold every single guard. And then what we return is just a function to remove the guard from the array. So the router is holding the array of guards, which makes sense because you're calling router before each. And you would expect that the router is the one handling pretty much, I mean, at least as much as possible from the guards, but it's not the case. If you look at the router push, sorry, this is all the code we have. We are just calling this.history.push, and we're just proxying the arguments there. That's it. Now, if we go into the history push, we're going to see that we have, well, this is a very simplified version, of course, but the first line is this, route equals this.router.match, blah, blah, blah. So it means that we are using the router instance to communicate. So we are going back to the router to get the match of the router or the route we want to go to. And then that once we have this normalized location, we can go on and do the navigation, which is a bit painful because it means that, and here I'm really simplifying the code, okay? The part that handles the navigation guards queue is not that easy because there are many callbacks implied. So we have function which are passing functions to other functions. We are taking functions in argument and calling other functions as our functions as argument. It's a mess. But the point is that once you go through that, you're gonna call history.pushState somewhere to change the URL, and then you're gonna call the incomplete function callback that you got from the push. And if there is an error, you're going to call the on error or on abort, whatever. So, sorry. If we take a look at the history class, what we have is a base class, which is the base class that is extended by the HTML5 implementation, the hash implementation, or the abstract, or also called in-memory implementation. And this base class is 300 lines of code. The HTML5 is only 70 lines of code. It's very small. There is almost nothing. And the hash is 130 lines of code. Now, if we take a look at the router, we have 200 lines of code for the router. And you may be thinking, well, the difference is not that big. And it's true, the difference is not that big. But the difference actually lies on the code base itself. The code base for the history is much more complex with all the complexity itself as its definition. In the history is much higher. You have callbacks nested in other callbacks. And in fact, the router class has many declarations, variables, or just simple functions that take the whole line. And I also tricking you here because there is also the matcher. And the matcher is 180 lines of code, but it's in another file. So we are not taking that into account. Sorry, I need to. So, what do we do here? With this not clear division of responsibilities, what we end up with harder to fix bugs. It's harder to add features. It's harder to contribute, and this is just go on and go on. And it's harder to extend. As a matter of fact, the native script implementation cannot completely use the router because we are not able to extend the history class. So this is a big bummer for us because it means that we are not able to provide something that other teams can use to extend the router. So what do we do to save the router? What are the next steps that we can and we should do to move forward and prevent all these technical debt just stays there forever? So remember these two APIs/responsibilities we're talking about before. We have the history on one side and we have the router on one side. And so as you can see, I'm highlighting on blue some part of the router, and this is a reason, obviously. So let's talk about the history. The history API is pretty clear. We have the push, we have replace, we have the listen. We talked about that before. Now, what about the responsibilities and expectations? What about limiting what the history is supposed to do and what it's not supposed to do? So one of the things is the history is supposed to modify the location. Now that makes sense. By a location, I mean the URL bar for a browser, but maybe the internal location for a mobile device, whatever you want. But it should be the history responsibility to do that, not the router, which is already the case, to be honest. It should also parse the URL. So it means that in the API, it may have some URL parsing tools like query, stringify query, parse query, etc. So it means that it should be able to separate the location into this path, which is the slash till the interrogation mark or the hash, whatever it comes first, whatever exists. Then the query, and also parsing that query into an object, so not having the actual string. So interrogation mark, search equals tortilla, and page equals 1, whatever. And finally, the hash, which is a string. It's not very complex. But it doesn't stop there. We also need the notify when the location changes, which is the listen function. And we also have the handle encoding problems. That's a funny topic, by the way. Very cool. It's also the moment to troll browsers very, very well. And it should be able to be overloaded. So it should be able for users who are using the router to provide another implementation of the history that change the behavior. The same way we have HTML5, hash, and abstract, we should be able to provide another one and use that one instead. Now, what about the router? The router, we could actually split the things in two. We have the navigation guards, the dynamic routing, and then we have the route matching and the out route records. So you can see that I also simplify the match and resolve into one function because we just need one after all. And we have this add route record and remove route record, which do not exist right now, to be fair, but it's just a way of how things could be. So these are actually the matcher and the router. They will be split into classes, two different entities that will communicate with each other. So the matcher is going to have in the API the resolve function, which is going to transform a row location into something that is more normalized, and it's also going to handle the adding and removing routes. What? Okay. What about the responsibilities and the expectations? It should be able to resolve the routing location to a router record. Now that makes sense. This is what exists in the router, nothing new. But it should only handle the path of the URL. The matcher doesn't care about the query of the hash. That doesn't exist in a route, in a location. Okay, this is an extra part of the URL. It's not part of a location in a route record. It should handle the priority of the route records. Now this is something interesting I'm going to talk about. It's a more complicated topic. And it should also handle and parse the params. So it means that if you write a route that is user/:id, it will recognize ID as a param, and then if you go to user, you want to resolve user/2, it will transform 2 into a string and say, okay, this is a param ID. And the other way around. Transform an object of params in an actual string, which will be the URL. So about the ranking. Now the ranking, and this is the reason that we cannot have declarative routing in Vue Router, and why dynamic routing has been stale for so long. You have PRs and issues about remove route, replace route, and it doesn't go forward because there are problems that come from the implementation of the router itself and how we approach routes. It should be changed completely. When you are creating the routes with a Vue Router, you are passing the array and you are controlling the ranking of the routes. You're saying which ones should be matched first. So when you do a push, what we do internally is we go through that array of the transformed records and we try to match every single route with the actual route you want to go to. Now, if you look at other routers, what they do is they rank routes so they can insert them in an ordered array. Now, this is the rich router ranking algorithm. It's not perfect, to be honest, because it's missing multiple parameters in one single segment. It doesn't handle that well, and I think there is in my opinion, a bug in the one with that 19 score with the star. But the thing is, we're going to split the route into different segments. So every single slash will create a segment. So for example, just a slash, that's one segment. Slash groups, that's also one segment. And you have slash groups slash mine, that's 2 segments. And you're going to give them a score. You're going to give a score to each one of them. And the way the algorithm for rich router works is that way. Each segments get 4 points. And then on top of that, if you have a static segment, you get an extra 3 points. If you have a dynamic segment, you get 2 points. And if you have a root segment, you get 1 point. And finally, the wildcard, so the star, is going to give you a minus 1 point. So that's why you have the explanation on the left of the point, the score. So for example, the root, that will be one segment is the root. So that's 4 plus 1, 5. Groups is one segment, so 4 plus the static segment, that's 7. Then the group slash group ID, you have 4 plus 3, and then 4 plus 2, and so on. Now the one with the wildcard is a bit different because it's not considering that when you have the slash, that's another segment, but whatever. This also doesn't work if you have multiple parameters. So if you have, for example, colon ID dash colon name or whatever, this algorithm wouldn't work, because you cannot say, like, you cannot run correctly the route when it has multiple parameter compared to other static versions. Because if you have one version that is static, so instead of having colon user dash colon whatever, and you have the whole thing as static, it will score less points, if you think about it. So it wouldn't work. The idea of the ranking here is the higher the ranking, you should match that one first. So for example, that's why groups/mine should be matched before groups/groups ID, because group ID could match anything potentially. So you want to first match the static one. So this is something that is not implemented yet, because as I said, it doesn't work with everything, so I need to go a bit further into research. But it's a very interesting topic and something that we'll go through in the future. About the router. The router still holds the current route, the push, the replace, the before each, and the dynamic routing, which will be the add routes and remove routes, probably. It also holds the lazy loading pages, which it already does, and the in-component guards, and the error handles. About the responsibilities and expectations. Now, this is important. Whereas the two other APIs were completely synchronous, the matcher and the history are completely synchronous. There is no await, there is no promises anywhere. The navigation for the router is asynchronous, because you have navigation guards, and inside of the navigation guard, you can do whatever you want. You can wait for fetching, you can wait for a timeout if you want to mess with your users or whatever. We have to trigger all the navigation guards, and it should be the responsibility of the router to do so. It should be the responsibility of the router to catch any error that happens in that queue. And then you have to expose that current location, which is the current route. You have to handle the redirections. So if you call next with a parameter, if you have a redirect field in a record, etc. Now, what about the browser quicks? Now, this is the funny part. This is when we get to troll other browsers. I know you love it, and I know what you're thinking about. You're thinking, yes, we're trolling IE. This is the moment. But the funny thing is that IE is not the only problem. We have other browsers like Safari for iOS. And this is one of my favorite parts. This is code from Vue Router on the left and code from Reach Router on the right. And it basically has the same try catch that you can see there. So on iOS Safari, I don't know exactly which version was, probably not the last one, but we never know. Safari throws an error when you have 100 calls to push state or replay state. So you just have to try catch that. And this is not something you can know beforehand. Of course, it's not in the spec or anything. You don't expect that. But it doesn't stop here. We can go even funnier with URI encoding issues. So imagine a server using HTML5. Now I'm comparing Internet Explorer 11, okay? Don't even bother about Internet Explorer 9 because it doesn't even support history HTML5. So we can get it out already. If you navigate to a route with some characters that are not ASCII, or ASCII, I don't know what this pronunciation in English, but because everybody here is Spanish, except for the French people here, and Coosto, you understand. So if we go to that URL, the spec for URL says that we should encode these characters. Now what happens in browsers, and there is a bug, probably a link for an image that fails, but there is also Safari there. I didn't forget about it. It's in between Firefox and Chrome. If you navigate to that URL, the browser is gonna encode those characters for you. So if you look at the URL bar, it will look like E with an accent, and I use just E everywhere just to show you exactly what it means. And if you look in the JavaScript and you check the path name in the browser, so in Safari, Chrome, and Firefox, you will see that you have the encoded version for the path name. So you're like, this goes with the spec, which is %, 2 hexadecimal characters, and this one, the E with an accent, needs 2 characters. I mean, it takes more than 1 byte to encode, so that's why we have 2 % there. And if we look at the search, the same. We have the %C3, %A9 equals %C3, %A9. And if you look at the hash, the same. This is perfect. This is very convenient. Now, what does IE do? Well, it doesn't give a shit. It just gives you the things, even though it doesn't respect the URL spec. Now, the reason it does that apparently is because they are following another spec, another RFC, it has another name, but basically another standard. So they don't consider this URL illegal. Now, in the browser, and this is another funny thing, if you copy the URL in the URL bar and you paste it somewhere else, you will see that you get the actual URL escaped, as you can see on location.pathname on the left. Except for Safari. Safari gives you the one with the accents. And if you paste it, it will actually encode the characters so they show in a way that is readable. With IE, there is no question because it just doesn't care. So it just shows everything. And you may be wondering, what about Edge? What about Edge, the new cool kid? Well, Edge stands close to IE here, but only in Windows. In Chrome, it doesn't. It behaves like Chrome and Firefox, so that's very cool, very funny as well. You have to check the user agent if you want to properly encode or decode these things. And the history push state I put there is because the behavior is exactly the same if you call history.pushState or if you directly navigate to that URL. So what about the cool new Vue Router? I've been talking about all the things from the past. What about the new things that are coming? What is the vision for the next iteration? The next iteration is, of course, written in TypeScript. The whole core will be probably written in TypeScript. And the idea is to provide more specific types. So, for example, a route record will be more explicit, saying you have a router record with a single view, or a router record with multiple views, or a router record with a redirect. So it will disallow, by typing, writing components and component in a same record, for example. And it will make the whole thing easier to contribute and easier to use because you will have the completion, which is great. We have a lot more tests just to prevent these regressions, which are very hard to find out, because every time you have a browser problem, a browser-specific problem, well, unless you have a test running on that browser, you're not going to see it. So we are trying to get a full unit test coverage, which is not the case nowadays. We have a lot of end-to-end tests, but they are not run into all the browsers we support, which makes it harder to catch the bugs. So the idea is now to use better tools to properly test these things, have a lower code base for end-to-end tests, so we can run these tests more often as well. So on every single pull request without having 5 minutes of CI running. We want to go slowly but surely. Now, why? Because it's very easy to build a prototype, go very quick, and then you get stuck with the wrong API because you release a stable version and you're like, oh, this is cool, it works well, and everybody's like, yeah, this worked well. And remember the first peak I showed you, first week, it's cute, 1 year is ugly. Well, that's what happened. 1 year later, you realize that things are not working too well, or are not flexible enough. And I think a good example of this is Parcel, for example. If Sean will here, we'll probably applaud, because I know he agrees on that. I mean, he's the one who told me to. That they want to support everything, they go fast, they actually are fixing a problem that exists on the developer community, but they haven't taken the time to go through the things to think before integrating things. Now, I'm not saying that Parcel is a bad tool at all. It's actually a good tool, but it takes them a lot of refactor to get to the point where we are today. It wasn't the same before. RFCs. So who have contributed to, by contribute I mean read or like leave a reaction or leave a comment on the RFCs on Vue in general? So little people. So we have a request for comments section on GitHub, a repository, where we publish the APIs that we want to go after or the things that we want to remove. And the idea is to be able to gather feedback feedback from the community, so we know if the direction we're heading is the right way or not, if we're missing completely our point, etc. And the router is no exception. So far we have, I think, 3 or 4 RFC opens. The most important there are the scope slot API for router links, which will provide a way to customize your router link component in a very specific way. Because nowadays a bit a hack, if you have a link inside, it will find that first link and add the click handler to it. Is not very good. The second one is better active matching. So it's because we have some behaviors that are hard to deal with or not intuitive in the first approach. Like the home, the root record, for example, is active all the time and stuff like that. And there are more to come, like dynamic history. This will go through an RFC to make sure that we find a good ranking pattern and other stuff. There is accessibility improvements that we want to go through, so make things easier for people to implement and give as much as possible from a default perspective. Although I'm not sure if we can do much except for the ARIA current page and ARIA current link things. And to provide more navigation information. So this is, are we going forward? Are we going backwards when we're navigating? Is this a push, a replace, a pop? A pop is when the user clicks on the buttons, the back and the forward. And we also want to provide some hooks API for the router link to make, just to go in sync with the hooks API. It should be able to work with both Vue 2 and Vue 3. So you'll probably see the version coming before Vue 3 is released. Well, that's what I hope. And should be pretty much the same API for Vue 3. And this is it for me. So I just want to first say thanks to my patrons. I'm starting to do this almost as full-time. So I rely on Open Collective and Patron to be able to work on Vue Router as much as I can. And by working on Vue Router, I mean working on the existing version and the new version at the same time, just going from one to the other. I hope you learned something today with me. You can find me on the internet as Posba, and thank you for your attention.